Hey guys, we're going to talk about how do you factor when you have a leading coefficient of 1. So to know how to factor, you have to know how to multiply. So back when you were first learning multiplication, you knew that 2 times 6 equals 12, things like that, and eventually you factored numbers. So if I said factor the number 12, for instance, you might tell me something like 2 times 6, but we weren't done yet. While those are factors, if we want, it's actually called prime factorization. You keep going until every factor is a prime number. And you would have said 12 equals 2 times 2 times 3. And those were the prime factors of the number 12, right? Because 2 times 2 is 4, 4 times 3 is 12. And it should multiply back to where you came from. If these multiplied together and did not equal 12, well, then we did something wrong because we were breaking down the number 12. But you can't do this. You can't factor the number 12 if you don't understand how to multiply to get the number 12. So it's kind of the same thing in algebra. You can't factor in algebra unless you know how to multiply. So we got to talk about how to multiply first. Let me give you a couple of examples. If I have like x plus 3 times x minus 7, and I ask you to multiply that, a lot of teachers would explain it by using the acronym FOIL. FOIL is just a set of instructions. It's the first numbers, the outside numbers, the inside numbers, and then the last numbers. It's just a way of reminding you of how to distribute. So the math term is called distributing. FOIL is an acronym that kind of helps you do that. So this is the process. You're going to make sure x and 3, both of these terms, have to hit both of those terms. That's the end goal when you're all done. So when we FOIL, we would do x times x. Those are the first numbers. X times negative 7, those are the outside numbers. 3 times x, those are the inside numbers. And 3 times negative 7, those are the last numbers. Now, we're not done yet. At this point, you would combine like terms. X squared minus 7x plus 3x minus 21. You would combine those, and you would get x squared minus 4x minus 21. All right. So the hope would be that you realize that there's a pattern here. And to keep in mind, we're only talking about rational answers, rational numbers. We're only talking about leading coefficients of 1. So we're not getting too crazy yet. We'll save that for another time. But in this scenario, there's a pattern here, right? What ends up happening is these two numbers are the key to everything. 4 is negative 3 plus 7, right? If I combine, sorry, I got that backwards, is 3 minus 7, right? We're combining 3 and negative 7. That's how you get the negative 4 there. The 21 is 3 times negative 7. So if we wanted to do this quickly, if we knew the pattern, we could skip that middle step and go straight to this. And knowing the pattern is crucial to knowing how to factor. So let's see if we can understand the pattern. Let's do another example of multiplication. Let's say we have x plus 5 and x plus 4. Now, following the pattern, we know it's going to start with x squared every time. X times x. Remember, it's 1x every time. But what about this middle term? The middle term is when you combine 5 and 4. Well, they're both positive, so they would combine to equal 9. And the last term is when you multiply them. So this would equal x squared plus 9x plus 4. If we did it the long way, it'd be x squared plus, first outside would be 4x, inside would be 5x, and the last would equal 20. So it is the same thing. So knowing that those two numbers add to equal 9 and multiply to equal 20 is huge. So how would we go back the other way? Well, let's say we started with this x squared plus 9x plus 20, and we were being asked to actually break it down, to factor it. Factoring is kind of like undistributing or unmultiplying. We're unraveling that process. So what do we know? We know that there are two numbers out there. They have to add to the number 9, and they have to multiply to the number 20. So we just need to find those two numbers. I mean, that's the goal. Now, a lot of teachers would teach this a lot of different ways. There's X methods, there's box methods. I'm not a big fan of those. Those are called graphic organizers. They're visual aids. They're really good for helping you learn things, but they're, at the end of the day, you have to be able to do this without them. It's kind of like when you were in kindergarten, when you first learned to add. You know, you had 1, 2, 3, you had 1, 2, and the teacher said, how many circles are there? And you would count 1, 2, 3, 4, 5, and you would say there's 5 circles. But at some point, you had to realize, hey, 3 plus 2 is 5. You just had to know how to do it. You can't draw pictures every time you have to do 3 plus 5. It's the same thing with factoring. You can't draw graphic organizers and visual aids every time you have to factor. You're going to be doing it way too often for that. So let's get pretty good at it. So the thought here is there's numbers that add to 9. Well, there's infinite choices. It could be 8 and 1, 7 and 2, 5 and 4. But it could also be 10 and -1, 11 and -2, 12 and -3, 13 and -4. I could do that forever. So that's a really long list. The other thing our numbers need to do is they need to multiply to equal 20. That's a much shorter list. If I took the number 20 and broke it down, 1 and 20, 2 and 10, 3, nope, 4 and 5. That's the entire list. It's got to be one of those or it's not rational. And remember, we're only doing rational right now. Okay, so from that list, what do? This is what I want you to look at. I want you to look at 20. So it's the factors of 20. We're breaking down 20. This symbol, plus, that tells me they have to add, and that's how I want you to think about it. And the answer needs to be 9. It's the factors of 20 that add up to 9. I want you to read that to yourself. We're reading it backwards. If you looked at it like this and you're like, okay, what do? It's the factors of 20 that add up to 9. That's your question that you're asking yourself. So look at our list. Do any of these factors add up to 9? 21, 12, 9. There it is. So we know we're talking about 5 and 4. We know the basic format, x and x. We know it's going to be 5 and 4. So then the last thing is I need to make 9, positive 9, out of the numbers 5 and 4. How do I get 9 out of 5 and 4? I'd have to add both of them. So that's x plus 5 times x plus 4. And looky there, that's what we started with. So we just undid the multiplication. I'm going to do a couple more. So let's say we have x squared minus 10x plus 16. All right. Now, everything I'm about to write in green is in your head. We're trying to do this in our head quickly. We're asking ourselves, what factors of 16 add up to 10? So 16, the factors of 16 that add up to 10. So we look at the list, or remember in green, we're doing this in our head. That equals 17, that equals 10, that equals 8. There's our factors. It's going to be 2 and 8. All right. So this is what you should be doing. Oops. We make our parentheses. We know it's going to be x and x. We know it has to be 2 and 8. How do you get negative 10 from the numbers 2 and 8? You would have to subtract them both. So it's negative 2 and negative 8 produce negative 10. And then negative 2 times negative 8 equals positive 16. Remember, everything in green you're doing in your head. You're asking yourself, what factors of 16 add up to negative 10? Okay, let's do another one. Let's say it's x squared minus 4x. Let's see. Minus 32. So a little bit tougher. Again, everything in green is in your head. What's the question you're going to ask yourself? I want you to think about it right now. What should you ask yourself on this problem? And you should be asking yourself what factors of 32, so it's 32, they have to subtract to equal 4. 1 and 32, 2 and 16, 3, nope, 4 and 8, 5, 6, no. So that's the list. These subtract to equal 31. These subtract to equal 14. And these subtract to equal 4. There's our numbers. Why subtract? Because it was minus 32. So I needed numbers that subtracted to equal 4. That's what I'm asking myself in my head. What factors of 32 subtract to equal 4? So I know the basic premise. I know it's x and x. I know that it's going to be 4 and 8, and I know that 4 and 8 have to give me -4. This is -4, by the way. So it'd have to be -8 and +4, right? If I did -8 plus 4, that's -4. If I did +8 and -4, that's +4. That's not what we wanted. We wanted -4. So it had to be a -8 and a +4. There's my factors. All right. So hopefully we know how to factor now. I'm going to do one more. You can pause the video so that you can try to do it. I'm going to go kind of quick through it. We're going to do x squared plus 10x minus 24. So pause the video, give it a shot. But you would ask yourself, what factors of 24 subtract to equal 10? You know it's x and x. 12 and 2 are the two. They have to equal positive 10, so those would be my factors. So what do we do in geometry? Because that's all algebra 1. In geometry, we'll have situations more like this. And I'm going to go kind of quick through this. We know that these are vertical angles, therefore they are equal. Your first priority is to make one side 0 while keeping x squared positive. Well, x squared's already positive, so I want to move everything from this side to the other side. So when I do that, add 3x, I would get -4x. Subtract 12, I would get -12, and now this side's gone. So I added 3x and subtracted 12 from both sides. Now it's what we were doing a second ago, right? We're just factoring this portion. You can pause it, try to factor it if you want. But we know it's going to look something like this. What factors of 12 subtract to equal 4? That's going to be 6 and 2, and it's got to be -6 and +2 because the answer is -4. Now this is where it gets a little icky. Okay, so we know the answer is 0, right? So let's think about this. Something times something equals 0. How do you get an answer of 0? One of these numbers has to be 0. It could be 0 times anything or anything times 0. Those are my options. Okay, so how do we do that? Well, we set each number equal to 0. X minus 6 might be 0, right? Test it out. What if I plug in 6? What is 6 minus 6? That is 0. What is 6 plus 2? That is 8. What is 0 times 8? 0. So yeah, if I plug in 6, the whole thing is 0. Or this one could be 0. X could be -2. Plug in -2. -2 plus 2, well, that's 0. -2 minus 6, that's -8. What is 0 times -0? So we're good. If either one of these numbers is 0, the whole thing is 0. So it's one of those answers. In Algebra 1, you would have been done, not in geometry. In geometry, we got to go back and plug them in. So let's plug in 6. If I plug in 6, I would get 6 squared minus 7 times 6. Well, that's 36 minus 42. Ugh. That's -6. That won't do it. I'm going to go ahead and plug it in over here. -3 times 6 plus 12. I do this to check my answer. Do I get the same thing? -18 plus 12 is also -6. That doesn't work. So 6 cannot be my answer. It does not work. An angle cannot be -6 degrees. It's out. It's not a reasonable answer. Let's try -2. -2 squared minus 7 times -2. A lot of people would mess this up. But that's +4, and that's +14. That's 18. That's okay. Let's try it over here. -3 times -2 plus 12. That's 6 plus 12. That's also 18. Boom, boom. So this is the only answer that works. All right, there's going to be a loud bell in a second. But I'm going to solve this one real quick. Pause it if you want. I'm just going to work it out. X squared plus 4x would equal -3x minus 10. So x squared add 3x would be 7x. Add 10 would equal 0. What factors of 10 add up to 7? It's going to be 5 and 2. Set them equal to 0. How do you undo plus 5? It would be negative 5. How do you undo plus 2? It would be negative 2. So my options are negative 5 and negative 2. Plug it in. Negative 5 squared plus 4 times negative 5. That's 25. 25 minus 20. That'd be 5 degrees. That's acceptable. How about over here? Negative 3 times negative 5 minus 10. That'd be 15 minus 10. That's 5. Okay, we're good. Let's try negative 2. Negative 2 squared plus 4 times negative 2. That's 4 minus 8. That's negative 4. Nope. Negative 3 times negative 2 minus 10. That'd be 6 minus 4. That's negative 4. Nope. Nope. The negative 2 doesn't work. X equals negative 5. The angle would be 5 degrees. There we go. That's factoring, my friends.